at questions 2 and 3. Sequence given in question 2 is arctangent of 2n, where n goes from 1 to infinity. Now for such questions, or rather for such sequences, it is useful for us to study the corresponding real-valued function that defines the sequence. In this case, we are going to define the following function, fx, which is going to be set as arctangent of 2x, where x is going to be a real number. And here you will notice that the way in which I obtain the terms of my sequence an would be precisely by restricting my function to the natural numbers. So when f is restricted to the natural numbers, our function fx here, then we shall obtain all the terms of our sequence. That's an important thing to note, because it means that when we want to study what happens as we send n towards infinity, one good way of looking at that problem is to examine the corresponding limit when x goes towards infinity instead of just n. So if we can understand what this limit is, and it turns out that it does converge, we shall see why, then we also can, by restriction to the natural numbers, find out what the limit of our original sequence is going to be. So let us now try to understand how we shall obtain that this sequence does converge and that the limit in this case is pi over 2. Let us note here first that, alright, if we set y to be arctangent of 2x, which is our function, then because the arctangent is the inverse trigonometric function associated to tangent, it means that we can rewrite this as x equals to half of tangent y. So just applying the inverse of the arctangent to both sides will give you 2x equals to tangent y, and therefore we obtain x equals to half times tangent y. So if we look at the graphs of these two functions, we can indeed see that the way in which you obtain the graph for arctangent of 2x is by reflecting the graph for half times tangent of x. So in other words, this part of the graph, because the tangent function is periodic, but in this case we are only interested in the part of the graph which corresponds to the bit from period minus pi over 2 to pi over 2. If you flip this around along, or reflect this about the line y equals to x, then you will get this graph for arctangent of 2x. Now as you can see from this graph, as I take x towards infinity, the graph is tending towards a certain value at this point. What is this value that it is tending towards? What is the limit in this case? It turns out that the limiting value is precisely specified from the graph of the inverse of the arctangent function here. As we take x towards infinity for the arctangent graph, arctangent of 2x, it corresponds to taking y towards infinity in this graph for half times the tangent of x. And you can see from this graph that as we take y towards infinity, the x value is certainly going to tend towards the value specified by the corresponding vertical asymptote. What is this vertical asymptote here? It's precisely pi over 2. So at x equals to pi over 2, we have a vertical asymptote for this graph. And because we are reflecting this portion about the line y equals to x, it means that this vertical asymptote is going to correspond to the horizontal asymptote which you see in the graph for the arctangent of 2x, meaning that we have this limit. The limit as x tends towards infinity for arctangent of 2x in this graph is going to be pi over 2, which comes from the fact that at this point we have a vertical asymptote at pi over 2. Consequently, by restricting our function arctangent of 2x to the natural numbers, we would take the limit as n tends towards infinity. It is contained in the case when you are taking x towards infinity, because in this case all the natural numbers are also going to appear as well. As you take x towards infinity, you would also be covering all the natural numbers 1, 2, 5, 10 and 15 and so on. This is what we mean by the restriction to the natural numbers. By restricting our original function f of x to the natural numbers, we obtain our sequence. And because of this, we can use the information about the function as x tends towards infinity to prove the corresponding limit for the sequence which comes by restriction. From this we see that the limit as n tends towards infinity of arctangent of 2n is indeed pi over 2. Therefore the sequence does converge. That proves question 2 for us.